Okay, good morning, everybody. It is Friday. Hoo-hoo, I know, big deal, Friday. What does it matter? What does it mean? It means nothing tomorrow. No homework, no lessons tomorrow. We'll come back on Monday. So yesterday, let's take it. First of all, if you have not finished Chapter 8, you got to get it done. Max just turned in a Chapter 8 test to me, and Max got an A on it. So see, it can be done. You can get A's. You just have to get it done. Good job, Max. Okay, so now, number 2. Let's take a look at the homework. This stuff is kind of hard, so I'm going to do my best to show you an easier way today. Vanessa texted me yesterday. She said, how do you know, Mr. Davies, where they intersect? I said, well, sometimes you have to guess. So if I take a look at last night's homework, here's my point. Goes straight down to the line here. So what is this point here? I guesstimated negative 1.5, 2.5. Okay, we're going to find today using Desmos how to get these points exact. So then I use my distance formula. I got about 5.8. Okay, number 2, same thing. I'm looking for where they intersect. They intersect right about here. Again, I had to guess. It's about 1/5 and about 1 1/5, and use my distance formula. I got about 3.3. Okay, number 3. This one I didn't need to guess. This one was pretty easy. It is actually negative 3, 4 after I graphed it, and 0.05 is up here. So I've got the 2 lines, and then I use my distance formula. I got it. Okay, number 4, I graphed 4 over here, and again, didn't have to guess on this one because the slopes are opposite. I got 12, 9 is where they intersect. 9, 12, and use my distance formula to get it, and I got it. Okay, 5, same thing on 5. Didn't have to guess. Found out exactly where they intersected at negative 1, negative 1. Used my distance formula to find out where the length, and I got an answer about 8.2. So today, today, how do we do this? Well, first of all, you can do it algebraically, and if you do it algebraically, I'll just show you how big the problem gets. So to do it algebraically, oh my goodness, you've got to come up with the equations, which I did come up with the 2 equations. And then after you come up with the equations, what you got to do is find out, here's the 2 equations. Whoops. Then what you got to do is set the 2 equations equal to each other, solve, and I got an x value. Then I plugged it in and got a y value. Then once I got my point of intersection by algebra, I used my distance formula and got an answer. Okay, now that can be done. However, is there an easier way? Yeah, let's let technology do it. So Desmos. So I've got Desmos on my phone, and as an app, let me go ahead and show you where it is. So here's my Desmos. Super handy. It's a free app. Costs you nothing. So if you have a smartphone, go to your app store, find Desmos. Okay, so if I go to Desmos, I can type in an equation. I just did this one. I've got a 1x plus 2, and I got a negative x. Oh, let's say maybe plus 4. And if I wanted to find out where they intersect, just tap on it. 1, 3. Okay, so then it's kind of handy. I can also get this on my computer, and I can go ahead, and hopefully you guys can see this. If I go on my computer and I want to just click, let's see, I want to try and find Desmos, so go to Google search. Okay, go to Desmos graphene. Okay, it's free, doesn't cost anything. Go to Desmos graphene, Desmos, and there it is. Also same thing, and we'll actually use this in today's lesson. Okay, so I put my computer away for right now, and let's take a look at today's lesson. Okay, so how do we do this? Here is what we're doing. So today's lesson, we're going to find 5/15/2020. We're going to find the distance between parallel lines. Okay, if we can get 2 points. So if we can get 2 points, which was that's what we're going to let Desmos do for us, then we're going to use the distance formula. Okay, big square root, right, of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Okay, so we need 2 points. That's our goal today, is to get 2 points. So parallel lines, what do you know about them? They have the same slope. Okay, we know that. Parallel lines have the same slope, same rise over run. So our goal today is to take a look at these 2 parallel lines and find out what the distance is, the exact distance. So the distance has got to be straight across, or perpendicular, okay? So what I know about the slope of this one, look at the slope of this one, it's up 2 over 1. I know it's 2 over 1 because of that. The slope of this one's up 2 over 1. So the slope of this one's 2 over 1. So to be straight across, or perpendicular slope's got to be a -1/2, okay? So let's see. If I choose this point here, then I'll have a y-intercept. I could choose any point, but I want it to go and intersect the graph at a point. So maybe this is a good spot to start, okay? Down 1 over 2, down 1 over 2. So when I connect the line segment, okay, let's call this point A. Okay, so I want to pick a point that's easy to get. Point A is at -2, 3. And this is point B, which I don't know. I could guess. Looks like it's about 1.5, 1. And it might be. It might not be. So what I'm going to do is let Desmos find out where it intersects. So I'm going to find out, and I want this line right here. Now what's the equation of this line right here? Well, I know the equation of this line, okay, the red equation, is y equals, looks like it's down 1 over 2, down 1 over 2, plus 2. Okay, I'm going to circle that. That's that equation. And I want to know the length, right? So I want to find out, I've got this point, I want to find this point, I want to find point B. So in that case, I'd better use this line here to find out where my red line and my green line intersect. So the equation of line B we know is y equals 2x minus 2. So what I'm going to do is put both those into Desmos. Now I'll use my phone because it's just handier. It's right here. And I'm going to type it in. Again, with you guys, if you want to use your computer, the computer's pretty handy too because it's a little bit bigger to see. But for me, I'm going to use my phone because it's not as awkward. So I'm going to type in these two equations. So let me back up. I'm going to go y equals, and I'm going to go -1/2 divide 1/2, move the arrow over, x plus 2, right? Okay, now let's get rid of this one. Y equals, and we're going to go a 2x subtract 2, okay? Okay, there they are. So what I'm really looking for is this point of intersection, which is this point here. Tap on it, and it's really a negative, it's a positive 1.6 and 1.2, so I was actually off on my estimation, wasn't I? So the point I'm looking for is a 1.6, comma 1.2. So 1.6, comma 1.2, okay? Now, if I want to find the distance, I'm just going to use my distance formula. So I'm going to go big square root of, and let's call this point here, here's my 2 points. My 2 points, A is -2, 3, and point B, because I want to find the distance or the length, B is 1.6 and 1.2. Okay, so x1, y1, remember x1, y1, because point 1, x2, y2. Okay, so I'm just going to use my distance one. I'm going to go 1.2, parentheses, nope, I'll go 1.6 subtracted -2 squared plus a 1.2 subtracted 3 squared. Let's see how much my calculator can do for me. That's a double negative, so plus plus. Okay, I'm going to calculate on. Let's see, I can let the calculator do most of this work. I can go 1.6 plus 2, and I'm going to square that answer, right? So that's going to be a 12.96 plus, okay, let's let the calculator do the work. 1.2 subtract 3, right? And I'm going to square that answer, which probably should be positive. 3.24. Add those together, plus a 12.96, and I'm going to square root 16.2, and I get a distance of about 4, awfully close to 4. Okay, Alright, let's take a look at example 2. We're going to, again, let technology do it. So let's follow this along. Again, if I get going too fast, just pause it, okay? Graph these two lines and find the distance between them. So first of all, they are parallel. We know that. So let's start at 5. 1, 2, 3, 4, 5. And I'm going to go down 4. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. Let me graph that line in. Okay. Get my ruler out. Okay, there it is. Okay, now the second line. Let's see if I have a different color here. Let's use blue. Start at -1. And again, down 4. 1, 2, 3, 4 over 1. But I'll go the opposite. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. And I'll graph that line. Now these two lines are pretty close to each other. So we've got to find the distance. Okay, so what I need here is a decent point. So I like this point right here because it gives me an easy equation, right? Because I can find the equation of this line because right there I know the y-intercept. So I need this equation. So I know that the slope of these lines, 4 over 1. So the slope of the line I want to draw, the perpendicular one, is -1 over 4. 4. So, taking my pen, I'm going to take, and I want to draw the perpendicular line, which I know is like right about there, but let's draw it correctly. So I'm going to go up 1 over 1, 2, 3, 4, up 1 over 4. Let's draw that line in. Okay, again, you guys, if I get going too fast, just pause it, think about it, come back, okay? Alright, now, here we go. I need this distance right in there. I need that distance. We've got to darken that different. I need this distance, this length, okay? So point A, I know point A is at 0, -1. Point B, which is right there, I don't know point B. So let's let Desmos figure it out. So before I do too much with Desmos, the equation of this line is y equals 1/4 x minus 1. Okay, there's that equation. And I want to find out where it intersects this line, which is this equation, okay? -4x plus 5. Where do the two lines intersect? Let's let Desmos do it. Okay, so go to my calculator, okay? Let's find out point B. So first of all, let's type that in. I need a -4x. Let's hold on. Let's go -4x plus 5. Boom. Let's get rid of this one and type in the other one. Y equals, and I'm going to put a 1/4. 1 divided by 4. Move it over. So you can put your x right there. Move it. See how I moved it over? X subtract 1. Okay? Now, what I'm looking for is that point right there. Tap on it. And so it's about a 1.4 and a -0.6. So I got a 1.4. So point B is a 1.4 comma -0.6. Okay, let me write that up there. B is a 1.4 comma -0.6. Okay, so again, just going to use my distance formula. D is equal to the big square root. Remember, here it is. It's x2. So I've got my distance formula here. Okay, I'm just going to do it. 0.1, x1, y1, x2, y2. So we'll go 1.4 subtract 0 squared plus -0.6 subtract a -1 squared. Double negative. See my double negative, plus, plus. And let's let the calculator do as much as we can, okay? So let my calculator do the rest. Let's see here. I can actually type. I want to show you how I can do this. I can go parentheses 1.4 minus 0 squared plus. See, I'm really like letting the calculator do a lot of this work. Plus a -0.6 plus 1 squared. See, why not let the calculator do most work? I got 2.2, so I want the square root of 2.2. Square root of 2.2. 2.12. There you go. So I'm going to go square root of that answer, and I get an answer about 1.45. distance is about 1.45. Okay? Alright, not too bad if you can let technology do the problem with you, okay? Mr. Sun should be so proud of me, right, Emma? Alright, okay, problem number 2. Or sorry, problem number 3. Okay, so I'm going to graph 2/3 x minus 4. I can do that. 1, 2, 3, 4 is down here. And I'm going to go up 2 over 3, up 2 over 3. And I'm going to graph that line in, okay? Graph that line in real quickly. So, get that line there. Now, we want a line parallel to it, same slope, right? Passes through 3, 4. 1, 2, 3, 4. Okay, so let's go ahead and draw that line. So we've got a point at 3, 4. It's got to be parallel, right? So the slope is 2/3. So I'm just going to draw it. So I want a parallel line through this point. So I'm going to go up 2 over 3, 2, 3, 2, 3. And I'm going to get this line right here. Connect the dots. I think this is fascinating. Huh? I don't. 2, 3, 2, 3. They've got to be parallel. Oh, there we go. Now they look a little bit more parallel. I don't know. There we go. Oh, that's because I didn't go. Well, either way. There it is. So, what's the equation of this line? This line is y equals. It goes right through 2. 2/3 x plus 2. Alright, that's good. I need that equation, right? Now, to be perpendicular. So what I'm doing is I want to find a line that goes through, okay? So I need a line that's going to be straight down like this, okay? So if I need the distance, I need straight down distance, right? So the perpendicular slope is the opposite of that, which is -3/2. So I'm going to pick a point, probably this one here, because it's the easiest to get the equation, because it's on the y-axis. And I'm going to walk it down. Down 3, 1, 2, 3, over 2. Down 1, 2, 3, over 2. And I'm going to go ahead and draw the line. Okay, so what am I looking for? Well, I'm looking for the distance from here to here. Okay, so I know one of the points, point A. Point A is at 0, 2. So I know point A is at 0, 2. Point B, what about point B? Well, point B is here, and I could guess, but I don't need to guess because I can get the exact answer from Desmos. Before I do that, I need the equation of line AB. The equation would be y equals, let's see, it's down 3 over 2 plus 2. So where do these two lines intersect? So we want to find out that point right there. And this line is the y equals my 2/3 x minus 4. So where do these two lines intersect? At point B. Let's let Desmos do it for us. So I go back to Desmos. Okay, let's get rid of the equation. So I want to get rid of this one. Y equals, let's do a 2/3, 2 divided by 3, move it over, x, got to move it over because you need to put the x there, not on the bottom. Subtract 4. Okay, and let's get rid of this equation. There you go. And I need this equation, which is a -3 divided by 2, move it over, so you can put your x there, not on the bottom. X, and then plus 2. Okay, so where do they intersect? Right there. And we'll round it to about a 2.8. Okay, so point B is about a 2.8, comma, about a -2.2 if I round it, okay? -2.2. Okay, so now we want to find the distance between 2 points. We need the distance formula, okay? And we know the distance formula is this big ugly equation, right? So what we need is an x1, y1, x2, y2. So distance or length is equal to the big square root of Let's see, we're going to go 2.8 squared. Oops, I'm so bad. Let me do that again. Sorry. I got distracted. That was writer. 2.8 subtract 0 squared plus a negative 2.2 subtract 2 squared. Now you want to see something really cool? You should be able to put this, if you have a good calculator, you can put the whole thing in your calculator just like this, okay? Clear. Got to go square root. You ready? And I'm going to go double parentheses, okay? I have to use double parentheses because I want square root of the whole thing. So I'm going to go parentheses. I'm going to go 2.8 subtract 0. Well, you don't really need minus 0, okay? Squared plus parentheses. I need a negative 2.2 subtract 2 parentheses squared. Answer, boom, right? There it is, about 5.04, 5.05. Isn't that cool? I let the calculator just do the whole thing, which you can do. So it's about 5.05. Okay, so hard lesson. Let Desmos. If you do not have Desmos, I guess the worst you could do is just measure the darn thing. But then you're not going to get a very good measurement because, you know, you're going to do it in centimeters, inches. It's not going to have the same thing. But, you know, I think everybody can get Desmos on their phone. Okay, so homework today is found on page 300, 6 through 10. All you're going to need to graph it and show your work. Okay, show work. There's a lot of work to do, okay? But there's only 5 problems, but it's hard, okay? So good luck. Let Desmos do it either on your phone or on your computer. It's actually a little easier to see on your computer. My computer is too big to show on the screen.